environment that you are working on. Especially we are relating this with Python. Okay, let me open a new Jupyter notebook. Okay, so Python data structure. First thing first, let's try to understand the definition. What is data structure? Okay, so what is a data structure? Okay, now here if you break these two words, data and structure. Okay, now when we talk about these two, you see uh, 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 what I can give is example. I can give an example is when we break these two words, right? Data and structure. What is it actually? Okay, we are talking about the format. Okay, how you organize, process, retrieve, and store data. Okay, so when we break these two letters, okay, data, okay. Now, what are the type of data you will find? Okay, can anybody want to try? What are the types of data that you can think of? Okay, now, i- what was that type? Yeah, see anything. See, phone directory. What is the type of data that you see in the phone? Okay, you have name, and next to it you can see the numeric type. Okay, the numbers. Okay, so numeric type, Boolean type, character type, non-null or null type. Okay, these are all part of data. Okay, now when we talk about data, again data you have structured, unstructured, and semi-structured data. Okay, so anyway, I think we have these topics, but anyway, I'll explain. Control Z, copy, structure, data, unstructured data, okay, and semi-structured. Okay, so these are the three type of data you will come across when you're working with any type of data: structured data, semi-structured, okay, semi-structured and unstructured data. Okay, now what is a structured data? Okay, what is a structured data? Okay, simple. Okay, if someone wants to know what is structured data, okay, structured data is something, the data in a format within like rows and columns. Okay, if I give you Excel sheet, okay, and your data is populated in rows and columns, right? So it is a structure. We can go line by line and you can understand what the data is talking about, right? Or we can call this as a uh, uh, a predefined data model. Okay, I mean, when we learn about SQL and all, right, we will learn about schemas. Okay, all these things. Okay, the jargons you will see in the upcoming classes. Okay, now see, I don't want to go in depth. Okay, now because we have to cover this when we are working with data real time, structured, unstructured, and semi-structured data. Okay, what is unstructured data? Why we called it as unstructured data?
Because it's not arranged in rows and columns and it is not organized
Correct,
properly.
correct. Simple data that doesn't have a predefined data modeling. Okay, we call this a data modeling. See, these are all the jargons I'll be using, and I'll explain all these things. What is a model? Okay, in SQL, when you see your data in the form of rows and columns, we called it is properly formatted. Okay, let me see if I have SQL loaded on this. Okay, this is a Postgres SQL. Okay, SQL stands for Structured Query Language. Okay, you'll be writing a simple English statement to query your data. You are currently running. Okay, blah blah. Okay, I'll just X out of this. Uh, okay, I'll just connect to my database. Uh, Pin 1, 2, 3, 4, 5. Hmm. I don't know what password did I say. One minute, guys. Give me 1 minute. Okay, I think there is some issue with the password. I'll just reset it later on. I think I added some password. I don't recall. Uh, I think it should be Postgres only. 1 minute. I'll try last time, or else I'll leave it. I'll reset it, and I want to show you the difference. Okay? Okay, that's fine. Uh, it is not working. I'll reset it tomorrow. Okay, I'll reset the password for tomorrow's class. I want to show you about the structured data. Okay, semi-structured and all you'll not find. Structured and semi-structured you'll not find. Semi-structured is something called log files. Okay, in your system, whatever the log files that you get to see. For example, if you go to event viewer, okay, and if I maximize this, okay, I have application logs. Okay, if I click on this, okay, now you see, okay, this is about event logs. Okay, now you see here just a general description about this error. Okay, and it gives you some detail. Okay, this is semi-structured. See, all are not structured properly rows. Okay, and if you go here, it gives you in a friendly view. Okay, this view that you see is XML or JSON, and you'll get XML is something like this. Okay, you can copy this and you can put it in a editor that will convert into rows and columns, and then you can copy. But see here how many entries are there. You'll have a lot of entries, right? So it's not possible. You need to ingest this data through some tool or using a Python code, right? So you have all this. This is example of semi-structured data. Okay. So you'll see something heading here about this error, and then you'll see details. Okay. What is the log name? Application has created. Source is DSA service. Some services from Windows. What is event ID? 1003. Level is information. Just information. Okay. Same thing if I go to system. Okay. You will see here you have a source, right? So these are not proper. This we can call this as a semi-structure. Okay, you have see this column, you have everything here, and then this here. Okay, and when you convert this data into a structure, you have to use a formatting to convert, and then you will store it in a database, and then you will uh, start your analysis. Okay, so this is just an example. Structured data is when a data is in the form of row and columns, we call it as a structured data. And unstructured is data that does not have a predefined data model or any proper structure. Okay, the example that I just showed you is semi-structured or unstructured also. Okay, what is semi-structured? Semi-structured data that doesn't conform to a strict structure of relational database. Okay, like in a form of Excel sheet, you take, you have rows and columns. Okay, it is not in the format, it's just a simple line. Okay, some gibberish. Okay, for example, I have name. Okay, Arun. Okay, age 36. Okay, and class 10. Okay, now you see this. Okay, this is semi-structured. Okay, so you have all in one row. Okay, but when you want to these type of data, you have almost like 100 rows. Okay, okay, so right now you can see there is a name. I've just copy pasted, but in this case you will have a different names. Okay, there are like 1,000 rows. Okay, so can you do the analysis? No, this is because it's semi structured. Then what you have to do is you have to convert this entire data, and you have to grab this first one as a first column, age as a second column, and class as a third column, and then whatever the corresponding data is that you see here, next to name Arun, age, and class, it has to come in a format. Okay, then you will convert that data, semi-structured data, into a structured data. Okay, and then you will start the analysis. Okay, this is just an example, guys. Okay, anyway, we have class on this. Okay, so in a simple format, I can say H3. Our data structure is a systematic way of organizing, yeah, organizing I-N-G, organizing data so that it can be used efficiently. Okay, this is a definition. Okay, a data structure is a systematic way of organizing data so that it can be used efficiently. Same example I gave you, structured versus unstructured versus semi-structured. Okay. And the other definition is a data structure is a format. Okay, what is it? It's a format. One H3. Okay, it's a format. Okay, it's a format for organizing, processing, retrieving, okay, retrieving and storing data. Okay, so if you ask me what is the life cycle of a data, organizing, processing, retrieving and storing data. This is what we do, right? If you ask me the life cycle of a data, okay, people ask you in question, okay, tricky question, what is the life cycle of a data? Okay, so you can say it's a format for organizing. It's a format for organizing, processing, retrieving, and storing data. Okay, I'll just make here list. Okay, uh, inside that I can say H2. Okay, and I can say data life cycle. Okay, so everything that you see around you, it has a life cycle management. Okay, for example, you take a mobile phone. Okay, so when it is released, you will buy it, and what happens is after 2 3 years it will become obsolete. Okay, because the vendor or OEM will not release any patches, okay, or any software support. What happens ultimately, you have to look for a new mobile phone, okay, if you want to support your applications. Same thing with laptop. Okay, after 3 years or 2 years, what happens? Your lab battery goes down. Okay, same thing with your laptop, mobile phone, and even AirPods and all, right? So these are all battery driven technology. So what happens is after 2 3 years, it stops working. Okay, so there is a life cycle for everything: product life cycle, data life cycle, okay, process life cycle management, and then you have other things also you can categorize into that. Okay. Mm, okay. Okay, so data lifecycle management is a organizing, processing, retrieving and storing data. Okay, now I'll give you some examples. Okay, uh, a best example is, think of a kitchen. Okay, think of your kitchen at home. Okay, now when you open the drawer, okay, you have a drawer, right, at a study table, right? So it's like a list. Okay, you put the eraser on the left hand side, you organize in the center, you'll keep your diary, and then you'll keep ruler on the right hand side, and then pens on the other end, and if you have charger or whatever things, okay, you will organize properly. Okay, so we and it can be ordered. Okay, you keep all in order. Say for example, you have two types of eraser or pen. What you do is you'll keep it on the right hand side in your drawer, and left hand side you'll keep other things, right? Pen or whatever, okay, glue stick or a stapler, you'll keep it on left. Okay, what you do here is order. Okay, you will order things in a proper way. Say for example, another example I can give is uh, a kirana shop. Okay, just assume you have a kirana shop, and at the same time you have a store inside. Okay, so outside it's a kirana shop, inside you have a small storage room kind of thing, where what you'll do is you will order all goods from DMart or wherever. Okay, I'm just giving a realistic example. You are getting all those things: soap, salt, edible oil, and all these things you will buy it, and you will dump it in your store. And then what you do is, when you go to the store, say for example I come to your shop and I'll say I need a oil. Okay, what you do is, oil is not there because you just received the order, and what you'll do is you'll go to inside room and you will look for, there is a pile of boxes. Okay, and you don't know where is which is where. Okay, what you'll do is you'll open each and every carton, and then you will look for a oil, right? And what happens is, okay, after that customer goes away, then what you will do is you will start arranging all that product that you have received in a order. Okay, say for example in a soap section you will put all your soaps, shampoo, and then edible foods like salt, spices, masala, or whatever, oil, okay, sugar and all. You'll keep it in one section, and the other section you'll keep other section, okay, like spices, all those things. Okay, now if you learn from this, what they're doing is, when you organize properly, right? And next time I come and I'll say I'm looking for salt packet. He knows where the salt is. So what he does is he goes directly to that section and he picks up the salt. Now, what is happening before and after? If you see, before there was a time taken because the data was not organized properly, right? So in the second scenario, the data, he was able to fetch that data. Sorry, the salt packet immediately because he know where is the salt. Okay, this is called indexing. Okay, so how database stores is, it creates a index internally. Okay, when you fetch again next time, I'm looking for all salt types, it will fetch immediately. Okay, these are the concepts that you will learn. Okay, so like I gave example is drawers. Okay, it's like a set. Okay, it's like a list, sorry. Okay, I'll add it here, example. Okay, so in the PPT and all, see, I have mentioned generic guys here. Okay, so a method of organizing data within a computer memory facilitate efficient access. Same thing, same example I gave you. Okay, if you don't define your data type and all, it will take time to fetch. Okay, the same thing I gave you the kirana shop. Okay, a grocery shop, where if it is not properly organized, even if you go to the Reliance grocery or Vijeta and other that is there near your home and all, right? So they arrange everything properly. Okay, first section you will see shampoo section and soaps. Second is uh, snacks. Third one is something else. Fourth one is vegetable, and fifth one is like rice pulses, rice, dals, and all those things, oils and all. Okay, if these, just assume if these are not properly organized, what happens is you will take time to search. What you will do is, first, as soon as you enter, you will have a list. Okay, you will say soaps. What you do is you will see soap section, it will be written at the top, right? So that is your index. So first you'll enter there, first you'll pick the soap and you'll put it in your cart, and then you'll move on. And after the training, after the shopping is done, you'll come back to your billing section, and then you bill it, pay, and come out of it. Okay, if it is not organized, just assume it is not organized, everything is piled up like a mountain. What has to, you have to go search, it will take a lot of time. Okay, same concept was picked up in database. Okay, same thing happens with data also. So these are all the same concept I'm going through with some examples. Okay, organizing, processing, retrieving, storing data. Okay, and it enables diverse data manipulation by users and computers. Same thing, if you have a new stock, okay, in your grocery shop, and you want to place those in a respective location. Index is, first row is, first section is soap, second is shampoo, okay, and third one is some other item. So you know which goes where. So you'll go and you'll manipulate all those new stocks with the existing one, and you'll place it properly at the location. Okay, so these are all taken from a real-time examples. Okay, so I have just a definition, but whatever the chart or whatever the this uh, Python notebook notes I'm preparing, right? So this will give you the in-depth knowledge about your I mean entire content that we are going through. Okay, now I'll just write it down. Okay, drawers are like list, ordered, ordered, and can be changed. Okay, 1 minute, guys. I have to change it to markdown. Okay, now second one is okay. Now the other data type that you will come, one is a list. Okay, one is a list. Another one is called tuple. Okay, tuple. Okay, now what is tuple? Okay, example, egg carton. At home you have egg carton, right? Egg stand, egg cartons. Okay, why it's called tuple? It has a fixed slots. Okay, fixed slots. Okay, and these are fixed, these are fixed and ordered. Okay, in the egg carton, can you place a onion inside? No, right? Because if the size doesn't, if you know the egg size, how does it look? Oval, right? So it will easily go and sit in the egg carton that we generally keep it in our fridge and all, right, or outside like a box, egg box, right? So it has a fixed slot. Okay, so only that data type will fit into it. Okay, we called it as a fixed slots, fixed and ordered. Okay, so you see all eggs are ordered. Okay, next one is set. Okay, these are all the type data types. Lists. Okay, now example is set. Okay, this is a very uh, I can give you one example. Okay, kitchen. Okay, think of your kitchen. Okay, you have a spice box, right? Masala box. Okay, so if you see inside that masala box, what happens is you have racks. Okay, small racks. You add jeera, then you have what is that called? Turmeric, mirchi powder. Okay, jeera, and all that you add it, right? Right, black pepper and salt and all, right? You will arrange in one rack. Okay, now this is an example of a uh, rack. Okay, spice rack. Okay, or spice masala box also you can call it. Okay, masala box. Okay, now what is happening is it is like a set. Okay, why do we call a set? Because all racks are with the same size, and it this rack will not allow duplicates. If you see the masala box, you will see all. If you have a 10 racks inside that masala box, when you open, you'll find different items there. Okay, so these are all taken from real-time examples, guys. Okay. And what I mean to say is no duplicates. Can you have two turmeric box in one masala? No, right? You generally don't keep it. You keep different items. So what does that mean? No duplicates. Okay. And the last one is this. I'll explain again, guys. Okay. This is just an example. It is coming in data lifecycle management. So I'm just covering this. Okay. Dictionary. Next one is dictionary data type. Okay, now what is a dictionary? Okay, it's like a labeled jars. Okay, now what is that? You have a jam. Okay, now you will see outside clearly it will say fruit jam or something else, right? So, and inside it has a content. Now what are things that it will come? It will have two things. Okay, dictionary will always have key value pair. Okay, and you can take as a dictionary also. I mean, if you have an Oxford dictionary at home, right, you will see on the left hand side the word and then the meaning. Okay, what is that? First thing is called key, and the second one is value. Okay, key value pair. Okay, in kitchen also you will see honey. Okay, you have two three types of honey. Okay, so some honeys are like uh, what is that called? How to differentiate honeys? One is organic, inorganic. Okay, and yeah, organic, unorganic. Okay, so you have a name called uh, heritage. Okay, and inside what is the value that you can think? Honey. Okay, name is heritage, value is honey. Okay, same thing. Other one is you can take Dabur and then organic honey. Okay, now here in dictionary you will see key and value pair. Okay, if I have a name here, it, and the name will come here. If I have age here, it will come as age. Okay, so don't get confused. This is very. These are the four types of predominantly data types that you will come across. Okay, in data science. Okay, now whatever the data that you see, these are some or the other way are in this format only: list, tuple, sets, dictionary. Okay, these are the four. Clear, guys? Yes, no? Okay. What about others?
Yes, bro.
Okay.
Yes, yes, Varun. Yes.
Yes, sir.
Okay. Now we'll learn why we need data structure. Okay. So we know the definition. Now, why do we need a data structure? Okay. You need to ask whenever you learn something, no, why? Why do we need to learn this? Okay. Where we'll implement this? Okay. How it will help us? What are the benefits? Okay. Now you have an old car. Now you are going for a new car. Okay. Now what is the benefit? Okay. Always we are humans. We need benefits, right? So one is mileage, one is cost, one is if it is electric, you are saving money on tax, right? You have a tax rebate from government if you are buying electric because you are not polluting the air outside, right? With electric car. So always you should have why. Okay. So that's a very good way of understanding why. Okay. Why? 1 minute. Why data? Why data structure? Okay. Now I'll explain. One is simple way. Okay, if you have a proper data structure like this: list, tuple, sets, and dictionary. Okay, one is your code will look good. Okay, or I can say write better code. Okay, second option that I can think of is organize. Nice, yes, yes, true, true, correct. Organized. Okay, and you can perform complex task. Okay, for example, uh, uh, just assuming that you are looking for some see I'll give an example: Google Maps pathfinding. Okay, example, you are looking for I mean someone is looking for sub location. Okay, so there is an invitation and you're looking for to go there. Okay, and what you do is you will enable your Google Maps, and then what Google Maps does is it takes point by point and it will guide you and it will take you to the destination. Okay, now behind the scene what is happening is it is taking the all the data points there. Okay, longitude, okay, on graph, and it guides you. Okay, even if you see you have a moving value also there. Okay, I mean if you take your data or if you're looking for someone's data. He has shared his data. Sorry, he has shared his map location. I mean current location, and he's starting from his location to your home. So you can see directly. Or the example is Swiggy. Okay, you order something and you see. Okay, a scooter icon is coming. It will show the estimation time and all that thing, and then it will give you the detail, the estimated time when is coming. Okay, what is happening is all coordinations it will calculate, and it will give you the precise location, precise time, and precise location where he has to reach. Okay, and so perform complex task if your data is properly arranged. Okay, perform complex tasks. Okay, next one. Next one is I can give a simple example is next one is you can prepare for your interview. Okay, so whenever you go any interview for data science, okay, they will ask you what are the four primitive data structures: list, tuple, sets, dictionary. Okay, sets is simple. Think of a masala box. Okay, you cannot have a duplicate. Simple. Okay, tuple, a carton, same fixed size and order. List, you will have different items. It can be ordered and it can be changed, just like a drawer. Okay, and dictionary is same like your Oxford dictionary. You have two values, key and value. Okay, so I can say DSA for interview purpose. Okay, it's called data structure. Okay, data structure algorithm, DSA. Okay, very famous. If you Google it, you will get to know. Okay, now the next one is which categories categories of data structure. Okay, now see, today we're going to learn only basics. Okay, probably tomorrow what I'll do is we'll do some hands-on. Okay, I'll pick up all this data: list, tuple, sets, and dictionary, and help you understand. Okay, so we'll sharp 9:30 we'll close the session. Okay, uh, yeah, coming back to categories of data data structure. One is linear. Okay, categories I can say linear. Okay, linear data. Okay, linear. Okay, linear data structure. Okay, I'll explain this what it is. Okay, when data is organized. Okay, when data is organized in sequence. Okay, when data is organized in sequence. Okay, now what are the examples that I can think of is, okay, list. Okay, tuple, then stack, queue. Okay, now let's spend some time. Linear. What is linear? Straight line. Okay, now queue. If you go outside near the cinema theater, what do you see? People are standing in a queue, right? So I mean, when we say the data is in a linear, means either it should be in a form of queue, stack. Now what is stack? Okay, stack is I can say a book of stack. Okay, so you place each first book, you will start with first book. On top of it you will put another book and another, likewise you will fill it up, right? And what happens is how does the data work here? When you fill when you stack up here, okay, you will pick up the not the bottom one, you will pick up from the first, I mean the last one. So we called it LIFO, last in first out. Okay, see, these are all examples, guys. This is first in, first out queue. If I'm starting at the beginning, okay, so obviously I'm get I'll get served first. Okay, in stack it is reverse. We call this last in, first out. Okay, so I'll show one example because this if you are clear with the I mean, okay, start example images. Yeah, okay, just assume this is your, okay, now you see this is mathematics, science, English, some language, blah blah blah. Okay, computer science, AI book and all is stacked here. Okay, when you want to read, what you do is you will read the top one first. Okay, if you see first one, which one is the first out of this stack? The bottom of the orange one, then yellow, then green, purple, blah blah blah. You have stacked it, right? And then when you want to use it, what you'll use, you'll not pick up the last one, right? The first one here, the concept we use it called LIFO, last in, first out. The last one that was placed at the top, you will use it first. Okay, you have all these expressions. See, in data, I mean, these type of concept will come. Okay, if your fundamentals are clear, right? When you get any data, I mean, it's a very, cakewalk for you guys to just start working on the data. Okay, so this is a tree data structure. Where do you see a tree data structure? Your family structure, right? Your grandfather, then below your father, below that your cousins and all that you will see. Okay, so this is a form of tree data structure. You are different, so data structure algorithm, when we have different formats. Okay, so we're gonna come learn all these things in a machine learning. Okay, we have something called deep learning and all that, right? We learn over there. Okay, so I just want to show. Okay, now this is the out, first in, last out. See, first one is from 1 I will start, and then I'll go to the 7th one, and here last in, first out, 7 to 1. So good examples are there. If you are not able to get any idea, simple, use Google. Okay, these are the concepts that you will come across with data. Okay, even if you join some data science course or anything, right, they will not teach, they'll just teach the concept. Okay, okay, so what is queue? You know, queue is first in, first out. Stack is last in, first out. The last one that you place at the top, he will the first one to serve. Okay, tuple. Tuple is same example here I gave you, egg cartons. Okay, which has a different slot, fixed and ordered. Okay, list, it's like a drawer. Okay, just think of a drawer at your home. When you open drawer, okay, you just assume in a kitchen you have a drawer. Okay, when you open, you will see spoons, tablespoons are placed on the right hand side, and then the forks are placed on the left hand side, and other uh, uh, spatula and other things are placed in a other location. Okay, but when you clean it up, okay, once in a month, what you do is you change the order, right? You keep it, the spoon, tablespoon on the left, right side you will change to fork, and then likewise, that is the reason we call this ordered and can be changes. Okay, and fixed and ordered. Okay, so these slots are fixed, you can change. See, you have 12 uh, slots in an egg box, right? You take the last one and you can put it there, and the first one you can take it and change it here. Okay, so I gave very good example here to help you understand. Okay, categories. Okay, categories done. Now we have another one called linear, right? We have another one called non-linear data. Okay, non-linear data structure. Now, what are the examples that falls under this? Tree, graph. Okay, same example. You have a family tree. Okay, your great grandfather, right? I mean, 10 generation. If you are managing, if you are maintaining all those photos, you will place the first photo, and after that, his son or daughter, and likewise, you will show all the generation, right? So that is in a tree format, or graph is something you can take an example of Google Maps. Okay, that's a very good example of graph where you can see uh, i- it will help you to navigate. Okay, and other one is, I think this is the last one. Okay, now data types. Okay, built in versus built in versus user defined data structure. Okay, now list. Okay, now what is built in? Built in is within Python. Okay, so generally you will see built in data types. What are the types? We just learned. Okay, list, tuple, sets, set, and dictionary. Okay, now what is the user defined? Okay, now what is the user defined? We'll come across linked list. Okay, linked list, then stack, queue. Okay, queue, and there are a lot. Okay, so I'm just giving few examples. Tree. Okay, so built-in versus user-defined is built-in is list, tuple, sets, dictionary. User-defined is linked list, stack, queue, blah blah blah. Okay, I've added all these things. Clear, guys? Yes? No? Sleeping? Am I audible?
Then, yeah.
Okay. So what's the time? 9:24. Okay, we'll stop it today because tomorrow we have to do some deep dive into built-in data structure. Okay, built-in data structure is list, tuple, sets, dictionary. Okay, if you relate, see whatever you're learning, right, you have need to relate. Okay, with real-time examples, and it will always stay in your mind. Okay, always stay in your mind. Okay, so sets is simple masala box. Okay, no duplicates allowed. Okay, you will find, so what is the example that I can relate here is employee ID. In a company you have employee ID, you cannot find duplicates there, right? I mean two employees cannot have a same ID. Say for example my ID is B12345 and another one is Sahib. Okay, and we cannot have same ID, right? So what happens is if we have same, obviously it will create a problem for HR for salary hikes and all. It will go to the wrong person. My salary will go to Saib and Saib salary will come to me, right? So that is the reason we maintain uniqueness. Okay. So based on these concepts only, all this came across sets. Okay. So that means no duplicates are allowed in a database for employee ID or project ID. If you have a project ID, you are working for, like in an example I can think of is in a company, you have different departments, right? Marketing, sales, HR, operations, okay, engineering, right? So we have different org. Okay, different org will have different naming convention for the employee ID. So if I'm falling under engineering, so it will have something with a company code abbreviation ABC 161C or whatever the number that will generate automatically in the database. Okay, so similarly that will be assigned to me till the life cycle. Okay, what is the life cycle? Till I leave the company. Okay, once I leave the company, that ID will not be assigned, vanish, gone. Okay, they'll not assign the same ID to anybody else. So next number the will be assigned to the next employee who is filling into my place. Okay, so this is about the life cycle management, guys. Okay, organizing, processing, retrieving, and storing data. Okay, these are the four inbuilt: list, tuple, set, dictionary. Okay, and why data structure? For better code, organized. Okay, complex stuff. You can perform complex if your data is proper, right? If data is not there, you'll spend a lot of time in cleaning up the activity. Okay, and interview purpose, this topic itself is a very famous, and most of the companies ask about data structure. Okay, whenever you think data and structure, you have to think about four. Okay, primitive type is list, tuple, set, dictionary. Okay, and what is non user defined is stack, list, queue, and tree. Okay. Okay, so tomorrow what we'll do is, guys, we will continue with deep dive session. Okay, with some code hands-on. Okay, data structures. Okay, I'll continue tomorrow. So we'll close the session today. Tomorrow same time 8:30. Please join, and then we'll continue. Okay, tomorrow we'll have some hands-on, but practice is must, guys. Okay, please do whatever we have learned till now. Open one by one and do a practice. Okay, now we are getting into the actual learning. Okay, so all those whatever we have learned 2 weeks ago and all are basics. Okay, even if you go to some YouTube, you will get it. But whatever we're gonna do hands-on and all, right? So nobody will teach you. Okay, you have to take some time and invest. Okay, invest your time in learning. Otherwise, it's up to you, guys. Okay. Chalo, guys, you can share the recording after this session, Sahib. Okay, so any question before we close this session? Is it clear? Any doubt about this data types, data structure? Any till here, or it is clear? Example, that's the reason I have made these examples. Okay, this will be very clear. Okay, so here dictionary is, I can give example Oxford Dictionary. Okay, example. Okay, so if you go to if you go, okay, I'll show you dictionary. Do you see dictionary data structure example? Hmm. Show you. Okay. Okay. Yeah, you can see here it is like 1 1 2 2. Okay, but see, when we learn all these things, right, by hands-on, then you'll get an idea about this. Okay, this is the same thing. Data types. Okay, number, sequence, Same thing I have just walk you through. Okay. So this also you can relate here. Okay. Int, float, Boolean type, and complex. These are the examples. Okay. I'll just copy this. This is a good one. Oops, I'm not able to copy this for some reason. 1 minute. Where is my snipping tool? No, right click is disabled there. Okay, right click is disabled. 1 minute. I can do that with snipping tool. Generally, what I do is I'll take a snip of this. Okay, now this is my snipping tool, and then I'll go back here. This is my snipping. I'll just copy this. Okay, I have to use markdown, then paste. See, I got it. If I save it, it will be like a PPT format. Okay, data types in Python. Numbers, under numbers you have integer, float, complex. Okay, under integer you have boolean. Boolean is nothing but true or false. Okay, sequence, strings, list, tuple, same thing we have learned. Okay, and mappings is dictionary, because in dictionary you will see key and value pair. Okay, and you have none also, null. Okay, in database, so in Excel you might have seen there might be some missing values or empty values. Okay, that is nothing but none data types. Okay, and sets is unique. Okay, and no duplicates. Same thing, masala box. Think of masala box. Okay, this is how you see whatever you are doing learning in your Jupyter notebook, right? You can just copy paste and do all. You can create reference, okay, within your own language also, and then it will be easy for you to refer if you are going for an interview or anything, right? Just refer all these things and go. Now you will learn tomorrow what is mutable and immutable. Mutable is something that can be changed. That data, say for example, age you have declared as 40. Okay, and tomorrow you get to know that that person's age is 35. What you do is, if you have defined that as a tuple, can you do that? You can do that. Mutable, you can see list and dictionary is mutable. In these two data structures you can change it. Tuple, once you declare, gone, you cannot. Say for example Aadhaar card. Okay, so once you punch in the Aadhaar card of a person, that is immutable. Nobody should change it, even the developer. Once declared is declared, because that's a critical data piece for you, right? So that is why we define variables in list, tuple, dictionary and all that, and then we define इसको change करना है नहीं करना है करके. ठीक है? So you have which site is this? TIFO. I don't know what it is, but oh, this is for kids. Okay, English, computer science, Python, introduction to Python, features of Python. See, you have good resources here. Statement, expression, operators. We have learned all these things. Okay, so even if you want to go through this, you can go identifiers. Okay, what are identifiers? You can go through it. We have videos also here. Okay, guys. Okay, so we'll close this session. We are on top of the hour, 9:34. We will regroup tomorrow same time, 8:30, and we'll continue with our lesson with new topics. Okay, chalo, bye guys. Good night. Good night.
Good night, sir.
Good night.